Hello, and today's purpose of the day is I can solve problems involving exponential growth, decay, and compound interest. Let's take a look at exponential growth. The formula for exponential growth is y equals a times the quantity 1 plus r to the power of t. Here, y equals the final amount, a represents the initial amount, r is the rate of change expressed as a decimal, and t is time. Let's take a look at the first question. In 2008, the town of Flat Creek had a population of about 280,000 and a growth rate of 0.85% per year. Part A, write an equation to represent the population of Flat Creek since 2008. So let's write down everything that we know. Well, we know A, the initial amount, is 280,000. So I'll write 280,000. I know that R, the rate here, is 0.85%, but we need to write that as a rate of change, which is expressed as a decimal. So I need to actually change this percentage to a decimal, which will be, I move the decimal over 2 places to the left, so 0.0085. Now, we just want to write an equation to represent the population of Flat Creek since 2008, so I can go ahead and put together my equation based on knowing those two variables. So my equation will be y equals my initial amount, which was 280,000, times the quantity 1 plus my rate, which is 0.0085, to the power of t, and then I can go ahead and simplify 1 plus 0.0085, and I'll get y equals 280,000 times the quantity 1.0085 to the power of t, and then that's my equation to represent the population of Flat Creek since 2008. Okay, part B now says, according to the equation, what will the population of Flat Creek in the year 2018 be? So now what I need to do is I need to plug in how many years is 2018 after 2008, and then that will be whatever t is. Well, 2018 is 10 years after 2008, so t will equal 10. So then I'll go ahead and write my equation from part A. So y equals 280,000 times the quantity 1 plus, well, actually, it's just 1.0085, and then to the power of 10, and I can go ahead and plug that in my calculator, round to the nearest person, and get 304,731 people. And that is my answer. Exponential decay is very similar to exponential growth in that there's only one change in the equation. So here the equation for exponential decay is y equals a times the quantity 1 minus r to the power of t, where a is still the initial amount, r is still the rate of decay here, expressed as a decimal, t is the time, and y is the final amount. Again, the only difference is now we're subtracting, which makes sense because this is exponential decay. So let's look at the first problem. During an economic recession, a charitable organization found that its donations dropped by 1.1% per year. Before the recession, its donations were 390,000. Question A. Write an equation to represent the charity's donations since the beginning of the recession. So again, we can write down the facts that we know. So A, the initial amount is 390,000. We know R here is 1.1%, so if I move that decimal 2 places to the left, it's 0.011. And then that's all I need now to write my equation. So y equals 390,000 times the quantity 1 minus 0.011, all to the power of t. And now I can simplify 1 minus 0.011 and get 0.989. So that final equation will be y equals 390,000 times the quantity 0.989, all to the power of t. Now the second question, estimate the amount of donations 5 years after the start of the recession. Well, now I just want to go ahead and plug in 5 in for t, so y equals, again, 390,000 times 0.989, all to the power of 5. And I can go ahead and type that into my calculator, and I get an answer of $369 and $16.74 for my answer. Okay, please take a look at examples 1 and 2 and answer what will the student population be in the year 2014 for number 1, and number 2, find the amount of donations after 3 years coming up soon. Okay, I hope you got both of those questions right. I have written out what the 2 equations you should use for the following problems that you had just solved. Hopefully, again, you got those correct. And as you probably had noticed, number 1 was exponential growth, again, because that keyword said growth rate. And number 2 was exponential decay, because again, that keyword said dropped. Okay, now let's take a look at compound interest. The formula for compound interest is A equals P times the quantity 1 plus R divided by N to the power of NT. So A here is the final amount. And occasionally it's okay to substitute A for Y and say Y equals, but here, the original equation with the variable they gave us was A, so the final ending amount. P here is the principal or initial amount, similar to the last equations that we saw. 1 plus R, again, R is the interest rate expressed as a decimal. N is the number of years, the number of times the interest is compounded each year. Again, N is in 2 different places here in this formula, and it means the same thing. And T is the time, and typically here it's given in years. So the definition for compound interest is interest earned or paid on both the initial investment and previously earned interest. It is an application of exponential growth. So a couple keywords that you'll see when you're figuring out problems that involve compound interest is annually. So again, this would be what N would equal. So how many times would this be compounded each year? So annually, if you hear that keyword, that means 1. Semi-annually means 2. Quarterly is 4. Monthly is 12. And daily would be 365. Let's take a look at a few examples of compound interest. Maria's parents invested $14,000 at 6% per year compounded monthly. How much money will there be in the account after 10 years? Okay, so let's write down here what we know. A equals the principal amount of $14,000 times the quantity 1 plus the rate here is 6%. So 6% as a decimal will be 0.06. Then divided by N, the number of times compounded per year. Here it's monthly, so that equals 12. And then to the power of N times T, again, N was 12 times 10. And now I'm putting that in parentheses because if I want to type this all in my calculator, I will need to make sure that I'm putting the correct parentheses where they need to be so that my calculator can figure out PEMDAS correctly. So if you type this in your calculator, you should get $25,471.55. Okay, let's look at another question. Maria's parents invested $14,000 at 6% per year compounded daily. So we're going to see what the difference between compounded monthly versus compounded daily will give us. So again, how much money will there be in the account after 10 years? So what I will do here is A equals my principal amount of $14,000 times the quantity 1 plus, again, the same rate, but now compounded daily would be 365, and then to the power of 365 times 10. I will go ahead and type in my calculator, and I get $25,508.41. Now please make sure you know how to type that into your calculator. And this makes sense that we should have more money because if you're, compounding on that money daily more times than monthly, you should end up with a larger amount of money after that after that compounded for 10 years. All right, you will see just a few problems of what is known as compounding continuously. So this just means that money is being compounded continuously for a certain amount of time. So the equation is a little bit different when we would solve for this. Here, this will be A equals P times E to the power of RT, where A is still the final amount of investment. That doesn't change. P is still the initial amount of investment. E now is a little bit different than what we've seen. This is actually a natural logarithm, which is approximately equal to 2.71828, and there's a button on your calculator that I will show you that we will use when we want to compound continuously. Again, that's what we use, that natural logarithm in this equation. R is still the annual rate expressed as a decimal, and T is the number of years in time. And we'll take a look at these examples in class together and in homework. Thanks for listening. Have a great day. Bye.